Hi students, my name is Dennis Hunchuk. I am your professor for the Introduction to Programming Concepts, course number COP1000C, and this course will be using a programming language called Python. Again, my name is Dennis Hunchuk. I've been at Valencia since 1994. I'm a full-time tenured professor. Went to California University, went to West Virginia University, married, 3 children. One's an attorney, one's a manager at Southwest, and another one is a real estate agent. What's class all about? Well, we're going to learn about some things about computers. We're going to learn how computers store information. We're going to learn something called software development lifecycle. A little bit about mind mapping, design tools, good programming design, and programming styles. We're actually going to learn how to write computer software using a programming language, not C, not C#, not Java, not JavaScript, but Python. This is going to be one of my first times using Python in this course, and I have added Python to the course rather than teaching it in C the way we used to because of the popularity of this language Python, and my thought is you need to know it. According to this website, techrepublic.com, April 2020, Python's #1 in demand by companies. According to Full Stack Academy, Python is #5. Depending on how you look at it, you might want to go to this site and see. But why is Python popular? Because it is very user-friendly. It's said to be clear, intuitive, and English-like, and so on. So I'll let you finish reading that on your own. We will be learning various programming concepts, such as how to do math in a computer program, what are variables, built-in functions. We're going to write our own programmer-defined functions. We're going to talk about input, output, something called a decision statement, repetition, and arrays or list. We're going to talk about stages in software development, which would be software begins with a program or a problem definition. We need a reason to design or to write software. Once we learn that reason and understand it, then we design our code. After we design it and test it and debug it, we actually code it. We do more testing and debugging. We document the code, and later we maintain the code. The first step is the problem definition. We have to thoroughly understand what the code's supposed to do. The worst thing you could ever do is write a solution to the wrong problem. Let's assume you go to a client's office and the client hires you to do a painting. Say you're an artist of his son. So he says, hey, make a portrait painting of my son. Well, then you have that boy or child pose, maybe for several sessions. You may take some pictures of the child or the boy so that you can use as you create the portrait. Might even take you a week or so to complete this painting, and then the client invites you to his or her house during the reveal of the painting. You present the painting, and all of a sudden the client storms out of the room. Turns out you painted a picture of a boy, but that boy was in the office that day when you met the client, but that boy or child was not the client's son. You created a perfectly good painting that did not meet the specifications of the client. Imagine your surprise. So be careful. Make sure you design software that the client actually wants. Never write a program unless you're 100% positive you understand the needs of your client. Imagine you're allowed to bring a calculator to a test, but instead you brought your remote to the TV. Oops. During program design, make sure you understand the problem. Do something called mind mapping and brainstorming, whiteboarding, and using design tools. Mind mapping is a technique. I recommend you go to Google and learn about mind mapping. You can use this the rest of your life. Brainstorming, you are going to get with others, possibly depending on the size of the project. You might sit down with the client and discuss things. You're going to write all your thoughts and ideas on a whiteboard if possible. Then you're going to use a design tool. Typically, there are 4 types of design tools: an IPO chart, a flow chart, pseudo code, and a structure chart. We'll talk about those in relationship to making pancakes. Pancakes. How do you make pancakes? Well, here's an IPO chart. First, the input to making pancakes would be mix, eggs, milk, bowl, and a griddle. So I need to get these items. Then I get the bowl, I pour the mix in the bowl, pour some eggs and milk, and I mix it up, and then I put this out on a hot griddle. I take the pancakes off the griddle, this is my output, and I put the pancake on a plate and maybe some certain butter, and I eat it. Here's an IPO chart. Again, the IPO chart that we just looked at has three parts: I for input, P for process, and O for output. Things I need, how I do it, and what comes out. A flow chart would be one of my design tools, and it's a graphical representation of the flow of your program. Flow chart for making pancakes. I start here, I get my ingredients, I mix them in a bowl, I pour it on a griddle, I flip it, place it on a plate, and then I stop to eat. Pseudo code, just a series of steps or statements. 1, get the ingredients. 2, mix it, pour on the griddle, flip, place on a plate, maybe add some certain butter, and eat away. Pseudocode is nothing but a series of English-like steps to solve a problem. Kind of think of pseudocode as maybe the set of instructions inside of a game you might have purchased. How do you play 1 potato, 2 potato? Step 1, form a circle. Step 2, put your hands together. Step 3, and so on. A structure chart. You can think of a structure chart as an organizational chart of a company. Structure chart uses rectangles and lines to show the order for an organization or for your program. Structure chart, ingredients, mix, pour. Once you pour, you flip, and you put on your plate. Example of a structure chart. Desk check your design. You're going to use a pen or pencil paper, and you're going to trace through whatever design tool you use to see if you get the expected output. Test, test, test. Might have to go all the way back to step 1, meet a client again, make adjustments, and continue. Eventually, you're going to begin to actually code the program. It's the first time you actually turn on your computer. You're going to open up your IDE, and you're going to begin to write your code. Summary. We're going to learn how to program, and hopefully we're going to learn good concepts. We've already talked briefly about different programming languages, but this class is going to be using Python. We'll talk about the other languages as we go along. Again, we'll talk about various programming concepts such as math and variables and decision statements and repetition statements and lists and arrays. We've talked about software development lifecycle, or we will. Program design, we just talked about that, and design tools. That's it for this module. See you in Module 2.